Yeah, this is what is constant. Yeah, and there is see like this. Let's say here, so very important now you see here. Now, yeah, y equal to x square. I'm just drawing y equal to x square. I think if you know this one, this is a parabola like this, a parabola, right?
Yes.
Parabola. Okay. So now this on set of real numbers, on set of real minus infinity to infinity. If I check minus infinity to infinity. So what happens is from minus infinity to 0, it is decreasing. First, it is
Yeah.
yes, it's decreasing. Okay.
Mm.
So on R, that means what? Minus infinity to 0. Okay. It's decreasing, right?
Mm.
Decreasing.
Strictly decreasing. Yeah.
Yes. And then 0 to infinity, you say it is strictly increasing. Okay. But
Yeah.
R, what you say, on R, you can't say strictly increasing, or you can't say strictly decreasing, or you can't say constant, you can't say anything. So what do you say? Neither increasing nor decreasing. This is the terminology we use. That means what? Neither we can say
Yeah.
it is increasing, nor we can say it is decreasing. That's the meaning. Neither increasing nor decreasing. You should say that.
Yeah.
Okay.
Okay. So shouldn't it be closed brackets at 0, the end of 0?
Yeah, doesn't matter. Yeah, you can close bracket, you can say.
Okay.
Bracket, you can say. Yes. Close bracket.
Okay.
You can include, no problem. Okay.
Yes. Yes, sir.
I think you got this point.
Yeah.
Okay, well,
Right.
you understand that strictly increasing, strictly decreasing, or increasing and decreasing constant function. And finally, what about this on all real numbers?
Yeah.
Increasing, not decreasing. But in a particular
Right.
interval, you can say it is strictly increasing, strictly decreasing.
Right. Right.
So this is the definition is what this one is the definition. So again, so just if I that diagram is not there, so actually, so now we'll go like this. So now like this. So it is strictly increasing. So now let's say this is x1 and this is x2. Anywhere you take x1, x2. So on intervals, so generally what do we do is on interval, first we'll discuss on intervals. And at a point also, you hear two things. So whenever we discuss increasing and decreasing, so we discuss on interval and at a point. So if you remember that continuity also we discussed at a point we discussed and also at a and in the interval we discussed. At a point also we can discuss it in the interval also we discuss. First we'll discuss in interval. So now this A and this is B. This is the interval. So now here, so from here, now if I draw a diagram, let's say a diagram is like this. Okay, diagram is like this. So now in this interval, I have taken this interval. So that means x1, x2 you take anywhere. X1 you take, let's say x1 is here, and x2 you take here. Any x1, x2 are any 2 points. X1, x2, x1 and x2 are any 2 points. This is x1 and this is x2. X2, any 2 points in the interval A to B. Okay, in this interval.
Yeah.
So how are we taking x1 is always less than x2? We are taking like this. Okay.
Yeah.
For x1 less than x2, if at all f of x1 is less than, this is the curve. What is this curve? This curve is f of x. So f of x1 is less than f of x2. What does it mean? As x is increasing, x1 is less than x2 means as x is increasing, f of x is also increasing. Understand? This is the definition is what? What is this? This is the definition. Okay?
Right.
For all, what we say for all x1, x2 belongs to A to B. Understand? That means what in the interval, whatever you take, whatever 2 points you take, how such a way that x1 is less than x2, then you get f of x1 is less than f of x2. So this is what is the definition. In definition, what you say is f is strictly increasing. This is the definition first. Okay, now let's take. So now let's take what about this? Let's say this is A and this is B. What about this? Now this is x1 and this is x2. So second one is
Yeah.
for x1 less than x2. That means as x is increasing, if at all f of x1 is greater than f of x2. For all, well, that means what? For every x1, x2 belongs to A to B. That means what? In the interval A to B, whatever you take x1, x2, what's happening as x1 is as x is increasing?
Yeah.
Decrease.
It's
Yes, like
yeah.
that you say. So then what we say? Then f is
Strictly decreasing.
decreasing like that.
Yeah.
So, but then what about that? Let's say for x1 is less than x2, okay? For x1, if at all, f of x1 is equal to f of x2. Okay, for all, this is for all x1, x2 belongs to interval A. What do we say? F is constant.
Okay.
Okay, then you see, so then if for x1 less than x2, f of x1 is less than or equal. That means what? Sometimes less than, sometimes equal,
Yeah, right.
Then what we say? Then f is
Increasing?
yes, increasing. Okay,
Okay.
say monotonically you can say. Okay.
Right.
X1 less than x2, if at all f of x1 is greater than or equal to f of x2. Then what we say?
Decreasing.
Just decreasing. So this is the terminology we use, right?
Yes.
Okay,
Yes.
where in the interval? So this is all in the interval.
Right.
Interval. This is all in the intervals.
Okay.
So this is what is definition. This is definition.
Yes.
So
Yes.
this interval, this should happen. As x increases, f of x also should increase.
Yes.
So this definition. Now, how do you find in the problem? Let's say now, okay, but let's take an example. Let f of x equal to we have 3x plus 5. Then what about this? Whether it is increasing function or decreasing function on all real numbers on its domain. Domain is what? This is a polynomial function. For polynomial function, what is the domain? On all real numbers. You can discuss on all real numbers whether it is increasing or decreasing. You can discuss. What is that? So now you can say for any you take for any x1 less than x2. Okay, for any x1 less than x2. That means what? Where do you take this one? X1, x2, you take in the interval. Here, remember. So what? X1 less than x2. 3x1 also less than 3x2. Yes, sir.
Yes.
3x1 less than 3x1 plus 5 also less than.
Yes.
So then f of x is definitely less than f of x like this. Also, you can say this is strictly increasing function.
Yes.
By using definition, you can do it. By
Right.
definition, you can.
Right.
But more than this, you can use application of differentiation. Applications of differentiation also you can use. So again, you see. Now let's our curve is like this. Okay.
Yes.
At every point you can find out. Or in the you can find. So at this point, you draw a tangent like this. Now slope of the tangent you see theta. Let's take this is theta, then tan theta. This tan theta only dy by dx. Okay.
Yes.
What is this tan theta dy by dx? Theta is acute. That means what? Theta is in the first quadrant 1. Then tan theta is greater than 0 when it is quadrant 1.
Okay. But isn't if tan theta is 0, then it's 0, right?
Yeah, you see, if it is increasing, you can observe here.
Yes, sir. Yes, sir.
Observe, yes or no? You can observe here. Here also, you can observe. Here also, you can observe. Yes or no? So wherever you want it, whatever point you want, you can observe that it is theta is acute, and then you see it is increasing means what? Theta is acute. So then tan
Yeah.
what greater than 0. Yes or no?
Okay.
So that means what f dash, or you can say r f dash of x is greater than 0. So that means what? So simply what you can say is, see, so this is in the interval also you can say, in the interval on domain, let's say f is a real valued function, okay, defined on the interval. So domain of the function, you can say domain of the function is D. Let's say this is the domain. D is the domain of the function.
Yeah.
D is the domain of the function, let's say. Okay, now
Yes.
if at all f dash of x is greater than 0 for all x belongs to D. Simple, I'm saying. Then,
Yeah.
then f is strictly strictly
Increasing.
than 0, greater increasing.
Yeah.
But don't remember like that, but you have to remember by using the diagram. See, use the diagram and then put like this, and the slope of the tangent, actually tan theta, dy by dx is what? F dash of x is what? F dash of x is slope of tangent to the curve. Okay, dy by
Okay.
dx or f dash of x, there differentiation represents actually slope of the tangent to the curve. So slope of the tangent is, positive. That is strictly decreased. Then what happens if it is sometimes, okay, it is decreased and then constant, and then sorry, it increased constant and then again increase like that. So here now this is okay. Then what happens here at this point? What happens is constant, no, like this. So it means what happens here, if at all f dash of x is greater than 0 but sometimes equal to 0 also for all x belongs to domain, then what we say, then f is you can't say strictly, then f is
Increasing.
increasing on D. Okay, like this, right?
Okay.
So in 3, so now let's say it is, what happens like this, it is decreasing, na? So decreasing, that
Yeah.
at this point, what happens like this? If you find out the slope, you can understand slope of the tangent at any point, you see, at this point or at this point or whatever. So its slope of the tangent is like that. Theta is what? Theta is obtuse. So
Okay.
tan theta is less than 0, second quadrant, obtuse. That means what? Theta belongs to Q2. So Q2 means what? Tan theta is less than 0. That means what? F dash of x is less than 0. Very simple. Okay.
Strictly decreasing. Yeah.
Yes.
Strictly decreasing.
Yes. So what you can say? Therefore, if at all f dash of x is less than 0 for all x belongs to the domain, whatever interval, if at all you are discussing on interval, you can say that is less than 0 for all x belongs to domain. Then what you can say?
Okay.
Then f is strictly decreasing on D. Okay, this is what is
Yeah.
4.
Yeah.
If at all f dash of x is less than or equal to 0 for all x belongs to whatever domain or interval, whatever is, then f is simply decreasing less than sometimes and sometimes equal also 5. If at all, what happens if at all f dash of x is always equal to 0 for all x belongs to whatever domain? What you can say,
Oh,
then f is
constant.
where it's constant.
Okay.
Okay,
Yes, sir.
now if at all f dash of x is, you can't say greater than 0, you see like this. You see like this, you have a curve like this, and here is one point, and now A to B you have to discuss is A, and this is B you have to discuss. Okay, and in between C is there. Okay, if at all f dash of x is greater than 0 for all x belongs to A to C, and also f dash of x is, no, this actually should write less, right? This is less than, right?
Yes.
This is less.
Yes. Yes.
Less than 0, and This is greater than 0 for all x belongs to C to B. You know, C to B. This is less than, no, here at this point it is less than. If you draw the tangent like this, it will come. You draw the tangent. So what you can say is f dash of x is greater than 0 for all x belongs to C to B. Then what you can say, here it is definitely strictly decreasing, here it is strictly increasing. But overall, okay, then what you can say, f is neither increasing
nor
decreasing on A to B. A to B, you can't say strictly increasing or strictly decreasing, whatever, increasing or decreasing, you can't say that. So therefore, we use the term neither increasing nor decreasing on A to B.
Yes.
This is application of differentiation. By using differentiation, you can find out whether it is increasing or decreasing.
Yes.
So now let's take some examples to understand this. So yeah, here I discussed on interval, but at a point, let's say you have to discuss at a point. At a point, how do you discuss at a point? Yeah. At a point, let's say at this point, you have to discuss. At this point means what, in this interval. So neighborhood, you have to discuss at neighborhood. That's it. At this point, okay.
Right.
What in this neighborhood you have to discuss. Right? You have to draw. Or you can say at that point you can draw the tangent and substitute that point and check that. Then also you'll be able to. As simple as that. So these are the definitions. Okay, so so here you have a question. So here is your question now. This question, what is saying? So that given function is increasing on all the numbers. You understand? See, strictly increasing means what it is increasing. You understand? If it is increasing, you can say it is increasing, no problem. But if it's increasing, then you can't say strictly increasing.
It may or may not be
it may or may not be strictly increasing, but if it is strictly increasing, you can say increasing, there's no problem.
Okay, so we don't need to specify that it is strictly increasing.
Sometimes he says, show that it is increasing. So then no problem. Understand.
Okay, right.
Strictly increasing, but monotonical sometimes increasing, sometimes constant, sometimes increasing. Monotonical means that. Increasing means what can be strictly increasing or it can be just increasing.
Yeah, okay.
So you should not worry. Sometimes he asks only increasing. Oh my God, this is strictly. So you find, see, f dash of x you found here. F dash of, so if you found f dash of x and you take 3 common here, if you take 3 common here, 3 times your x square minus 2x plus this 4 you write as 3 plus 1. Here 3 times 1 plus. So here what 3 if you take common, no, here a square minus 2 plus b square form. So a minus b whole square. So 3 times x minus 1 whole square plus 1. So a square is positive plus 1 is positive. So that means what is f of x is positive. Therefore, what you can say it is strictly increasing on all real numbers. You take x whatever real number on all real numbers. For all real numbers greater than 0. For all real greater than 0. So therefore, you can say it is strictly increasing. You can say why is saying only increasing? You may ask question. So it is increasing means no problem. It is increasing also. So there is no problem. Okay. Now next. Next question. See here. So what is that? Prove that the function cos x is increasing, decreasing, increasing, neither increasing, not decreasing, like that. So it is the interval. So now you find immediately function. So whenever we have tested, so increasing, decreasing, you have to immediately find f dash of x, which is what? Minus sin x. Yes, sir. So now f dash of x you need to find out. So what is that sin x? So sin x is greater than 0. Where sin x is positive? When x is in the quadrant 1 and quadrant 2, all silver tickets. First quadrant, second is positive. So then minus sin x is, you want minus sin x which is less than 0. Okay, in this quadrants.
Right.
So that means what? If dash of x is less than 0, where? So first quadrant, second quadrant, that means what? First quadrant.
Okay. So 0 to pi, it's decreasing.
Very good. 0 to pi. Okay. 0 to pi.
Is it strictly or just decreasing?
But what happens, at 90,
Yeah, 90 is the problem, right? Goes to 1
no,
and then it
not
starts
90,
decreasing.
at 0 and pi. At 0 and pi it is 0, right? Sin x, sin x is.
Yeah.
So no problem. 0 to pi it is strictly. Okay. On 0,
0 to pi strictly.
strictly only. 0 to pi it
So
is.
if it's both, if 0 cause 1, okay.
Sin, no, sin. F dash of x. We have to find f dash of x. Okay.
Yeah, so it becomes 1 at
Pi by 2.
okay.
Yeah, pi by 2. So there's no problem. So 0 to pi, that's why I'm saying strictly increasing. Strictly increasing tensor.
Increasing. Okay.
Okay.
So isn't it sine 0 is 0, then
Yeah,
sine
yeah.
90 is 1, and then sine 180 is 0 again, right?
Yeah, again, yes. So that's a strictly, yeah, less than 0, no? F dash of x is less than, strictly decreasing on 0 to pi. Okay.
Strictly decreasing.
F
Yeah,
dash
so
of
this
x
is
is less than
minus
0.
of sine. Minus of sine x, right?
Yeah. F dash of x minus sin x, no?
Yeah, right.
Minus sin x, what about minus sin x? So sin x is greater than 0, first and second quadrant. Minus sin
Yeah.
we need. Minus sin x means f dash of x. F dash of x is less than 0 on 0 to pi.
So sine, yeah, it's greater than or equal to 0, right? In quadrants 1 and 2.
Y equal to 0. Open we put now here.
Open bracket.
Pi is not there.
Okay. Oh, okay, right. So yeah, got it. Yeah.
So the next one, so first and second quadrant, but whereas sin x is less than 0 on second, third and fourth quadrant, Q3 and Q4, right? So that means what? Minus sin x is what? Greater than 0. On Q3 means what? So it starts from pi to 2 pi.
Okay.
So that is f dash of x is greater than 0 on pi to 2 pi. So therefore what you can say? F is, when f dash of x is greater than 0, f is increasing on pi to 2 pi, right? So obviously from 0 to 2 pi, if you take now, it is here decreasing and then it is here increasing. That means what? 0 to 2 pi, if you say, then neither increasing nor decreasing.
Okay.
So that's the application.
So it would just be decreasing in quadrants 1 and 2, right? Not strictly, right? It's just decreasing.
Quadrant 1 and 2.
It's not strictly, right? It's just
Why
decreasing.
why it's not strictly? It is strictly only. No? 0 is not there, pi is not there. Where is 0? It is the less than 0,
Yeah.
strictly decreasing. Strictly less than 0, strictly decreasing. Where it becomes 0, it will.
So half, and then it becomes 1, and then it goes down again, right?
No. Nice. Where is half and all?
Half when it's pi by 2, right?
Yeah, when it is pi by 2. When it is pi by 2. Actually, you are talking about the graph.
Yeah, so if
Okay,
you, because the
okay,
value
let's
of
see that.
sine at, let's say, 30 degrees is half, and then at 90 degrees it becomes 1, so it is increasing and then it's decreasing after that, right? So
Yeah, 0 to see. Okay, I am drawing the graph for your understanding.
Okay.
0 to pi you want, right?
Yeah.
So 0 to pi. Oh, so 0 to pi you are saying we have. So we are talking about what? Cos x. You are seeing sin x graph. The function cos x, but you are seeing sin x graph. That's why I draw it. Okay, so cos x 0 पे 1 होगा, and when it comes to pi by 2, 0 होगा, like this. You are seeing the graph of, then why it is this? ये वाला तो pi होगा, -1, 0 पे 1 and -1 here. is minus 1. You understand? Is it completely decreasing or not? The cos x graph 0 to 2. The cos x is
Cos.
decreasing, huh? Yes or no?
So we're doing the cos x graph, not the sin x graph.
Yeah, obviously, na, f dash of x is sin x.
Yes.
Yeah, like that.
Okay.
Okay, so what you can do is